In the world of GraphQL, flexibility and customization are key. That's why we're excited to introduce you to one of our most powerful features in the Grafbase Gateway, hooks. Our customers frequently request specific customization that don't fit neatly into our generic feature set. For example, large enterprises and financial services often need complex authorization strategies and have high security demands. These customers share a desire for custom solutions, sometimes utilizing proprietary services without an open protocol. Instead of implementing these features for everyone within the gateway, which could become overwhelming and yield diminishing returns, we take a different approach. Some of these customer needs include custom authentication mechanisms, data authorization based on input or output, proprietary caching services with unique protocols not publicly available, specific logging requirements and custom formats that do not adhere to common logging patterns. So, what exactly are hooks? Simply put, they allow you to load a custom WebAssembly component at specific points in your GraphQL request execution. This means you can inspect, manipulate, or extend your requests in ways that were previously impossible. In this video, we'll take a closer look at how hooks work and show you some practical examples of what you can achieve with this powerful feature. From debugging to optimization, hooks open up new possibilities for GraphQL development with the Grafbase Gateway. First, what we do is we create a new WebAssembly component with a tool called Cargo Component. This is a command line tool specifically designed for building and managing WebAssembly components in Rust. To get started, you'll need to install Cargo Component from their GitHub repository into your Rust programming environment. Once installed, you can use Cargo Component to create a new WebAssembly component. This will set up the basic structure for your component, including the necessary files and dependencies. In this case, we're creating a new component called Request Hook. The Cargo Component tool takes care of setting up the initial files and dependencies for us, so we can focus on implementing our hook logic. Now that we have our WebAssembly component created, it's time to define the hook itself. In Grafbase, hooks are defined using a WebAssembly interface type file. The wit file describes the hook definition that the gateway must call, as well as the types shared between the gateway and the hook. This is also where we specify the input and output types for our hook, which will be used to exchange data with the gateway. We can download the hook's wit definition from the Grafbase GitHub repository to our project. Now that we have our wit file defined, it's time to integrate our WebAssembly component into the Grafbase Gateway. In later videos, we will go deeper on what to do with the other available hooks, but now we only export the gateway request. The hook takes two input parameters. The first one is the context, which has a key value store available in all hook calls, together with a few system functions. We will come back to that in the later videos. The second parameter exposes the request headers. If we compile our code now, the compiler will give us an error for not implementing the interface correctly. Let's clean the default implementation and implement the required code for our hook. We define an implementation of a trait generated into the bindings module from our wit definition. We can use the editor's code actions to generate the needed boilerplate. Now we have a choice. We either return OK, which will continue the request execution. By returning an error, the request execution ends, and the error is returned to the client. This code looks into a header X custom, and if its value is a string secret, we continue execution. In any other case, the gateway returns an error with a custom message and extensions. Now our implementation should be working. We compile the WebAssembly component in release mode. The file gets generated into the target directory of the request hook crate. By including this file to our gateway configuration, our hook will be executed for every request. We already have a small subgraph running in the background. We provide the gateway a simple federated schema together with the configuration to get started. Let's launch the Grafbase Gateway with the configuration. Let's try issuing a few GraphQL queries. And we get a successful response back. If we change or remove the X-custom header, we see our hook preventing execution. This was only a small taste what is possible with Grafbase Gateway hooks. You can find instructions on installing and using the Grafbase Gateway from our documentation, grafbase.com, docs, self-hosted gateway.